Welcome to section 5.2. I know we may have skipped over a few other sections, but in the grand scheme of things, we can certainly afford to, given where we're at this semester. Let's talk about logarithmic functions. That's what 5.2 is about, logarithmic functions and properties of logarithms. If you remember back when we talked about one-to-one functions, we talked about how every operation in math has an inverse function to it. You know, the inverse to addition is subtraction, and vice versa. Well, the inverse to exponents is logarithms, and vice versa. So logarithms are really just the other side of the coin when it comes to exponents. And there are a bunch of properties and rules that we want to observe when it comes to logarithms and exponents. But the first one we want to talk about on page 327 is the definition of log. As you can see on the screen here, the definition of log is y equals log base b of x. And the way that it goes is it turns into b to the power of y equals x. So even to solve a logarithm, you need an exponent to do it. Now, if you see a log that doesn't have a base to it, most logs have to have a base unless it is a log base 10. Then just the word log implies a base 10. And then the other special kind of log that we have is called a log base e, which we call ln or natural log. So if you see ln, it means a log base e. If you just see a log with no base, it means log base 10. Otherwise, you'll see log with a base number attached to it as a subscript. All right, let's take a look at example 1 on page 327. It says, write each of the following exponential equations in logarithmic form. And it starts out with part A that says 3 squared equals 9. All right, so how do we convert that? Well, again, if we kind of look here at the definition of log, the b in this case is going to be 3. The y is going to be 2, and the x value is going to be 9. And so when we have that, it should be a simple matter of saying that this is the same as saying log base 3 of 9 equals 2. All right, so it's just converting it from exponential form to logarithmic form. All right, part B, we have 4 to the negative 1 power equals 1/4. And once again, we want to say identify each part. So the b, the base, that's why it's called b, is 4. The y value is negative 1, and the x value is 1/4. And so now we're going to have the log base 4 of 1/4 is equal to negative 1. Moving on to part C, we have 5 to the 1 is equal to 5. Now, of course, all these are true statements, right? 3 squared is 9. 4 to the negative 1 power is 1/4, and 5 to the 1 power is 5. Right? So all these are true statements, as they should be. All right, so our base is 5, our x is 5, and our y value happens to be 1. So what we're going to see is that the log base 5 of 5 equals 1. And this is really a true statement for any log, that if the base number and the x number are the same, the answer is always going to be 1. All right, and then part D here, to finish this particular example up, we have x equals 3 to the y. Now, the order is a little different than what we've seen here, but in our case, the base is 3, the y is y, and the x is x. All right, so that means that our log base 3 of x equals y. So a simple matter of using the definition. Definition is one of the most powerful properties of logarithms, and that's why it's the first thing that we talk about. Okay, so let's clear this off, and let's go the other way. Let's take a log and turn it into an exponent form, which is what example 2 is all about. All right, in example 2 on page 328, we're going to the other way. We're taking a logarithmic form and converting it to an exponential form. All right, so we have part A on this one. And A says that we have the log base 2 of 16 equals 4. All right, so the B, if we look at this one, is 2. The x value is 16, and the y is 4. So the way we're going to convert this is we're going to say 2 to the 4 power is equal to 16. And again, that's a true statement. If I take 2 to the 4 power, I'm going to get 16. So if for some reason I got the 16 and the 4 confused, what you would see is 2 to the 16th power certainly does not equal 4. That's not a true statement. Okay, part B, we have log base 10 of 0.0001 equals -4. It took a little bit longer to write that one out than the first one did, so we'll do the answer below here. But we know it's going to be 10 is our base, our x value is 0.0001, and our y value is -4. So that means that 10 to the -4 power is equal to 0.0001. And if you're not sure about that one, use your calculator, but you will find that this also is a true statement. When we see a negative power, we see a decimal answer. When we see a non-negative power, we see a answer that does not require decimals. So those are, again, two statements that are true as part of this actions that we're taking here. And then part C, we have log base 6 of 1 equals 0. So our base, once again, is 6, our x value is 1, and our y value is 0. And so this is also a true statement because it says 6 to the power of 0 equals 1. And again, we know that to be a true statement because anything to the power of 0 equals 1, with the exception of 0 itself. 0 to the power of 0 does not equal 1, but that is the lone exception to the power of 0.